How to set up your LiDAR by Hampus Månefjord 2023. Step 0. Transport the LiDAR. When packing your LiDAR, it's important to group related items in the same box. Fragile items like cameras, lasers, and telescopes should not be packed with heavy items that could damage them. Ensure that any protruding parts are either removed or well secured, and add sufficient padding to protect fragile components and prevent heavy items from moving during transport. Step 1. Assemble LiDAR. Begin by assembling the tripod, then attach the counterweights as far out as possible. Next, attach the baseline. While doing this, carefully disengage the azimuth and altitude axis, ensuring you're holding the baseline securely to prevent any accidental movement or damage. Step 2. Balance. The balancing process involves adjusting the azimuth axis by loosening and sliding the dovetail under the baseline, and similarly adjusting the laser axis by sliding the dovetails under the telescopes. Additionally, balance the altitude axis by sliding the counterweight. It's crucial to check that all axes move freely and stop without falling before tightening the engaged screws. Step 3. Align telescopes to termination. This step requires inserting the monitor camera into the receiver telescope, commonly known as Newton. Then, jog the tripod until the termination is centered. After that, move the monitor camera to the monitor telescope and adjust the screws until the termination is once again centered. Finally, place the monitor camera at the laser expander and adjust the expander's overlap and skewness screws to center the termination. Step 4. Connect and start LiDAR. Replace the monitor camera back to the monitor telescope, ensuring it faces up from the ground. If you're using a polarization LiDAR, position the laser away from Newton, while for a dual-band LiDAR, follow the orientation shown in the provided image. Insert the LiDAR sensor into the receiver Newton telescope, ensuring it is oriented correctly and points directly at the laser. After connecting all necessary cables, start the lab view code, turn on the laser, and confirm that the laser spot and the termination are visible and correctly displayed. Step 5. Alignment. For alignment, focus the laser until it's sharply imaged onto the termination for static measurements, or adjust it until the laser spot's width matches that of the laser expander for sky measurements. Adjust the focus of the Newton telescope to narrow the signal as much as possible, avoiding a double peak. Then, jog the tripod to face the sky and adjust exposure settings to achieve a stronger signal and a higher frame rate. Rotate the sensor around the azimuth axis to show the air signal as a peak, then adjust the overlap until the peak is at the center pixel, 1024. After rotating the sensor back to maximize the air signal across the sensor, adjust the slant of the laser to position the infinity signal at the edge of the sensor for sky measurements, or the termination peak for static measurements. Fine-tune the overlap for the strongest air signal, and adjust the Newton's focus to achieve the sharpest possible drop in signal intensity. Step 6. Finish up. Finally, jog the tripod back to the termination point. Adjust the camera exposure settings to your preferred levels for the measurement and start your measurement process.